Here's another question. Find a work done by the force field F of xy is equal to y to the second, comma xy on a moving object along the path y equals e to the x from 0, 1 to 1e. We need to first parameterize y equals e to the x so that we can use its vector form to calculate the work. Understand the graph of y equals e to the x looks like this, and you can get that from a table of points x comma y. We let x equals to 0, e to the 0th is 1, and 1 e to the first power is just e, so it's 2.7, so it just keeps going forever. But we're looking at a specific domain range values from 0, 1 to 1e, so we need to parameterize the function y equals e to the x. We can substitute x as t, and therefore by the substitution property, y is equal to e to the t. Now from here, we can parameterize the function where t is your x value and then e to the t is your y value. Up to this point, we need to now identify that this is our direction function. And then from here, we can take the derivative. So the direction of r prime of t is equal to 1 comma e of t dt. And this is for any t values from 0 to 1. By the work function, work total can be calculated by using the formula from a closed interval. So we have the force times it by the dot product, the derivative, and then that's essentially what we have as y to the second and xy. So I'm just going to rewrite this in its vector form, then we can multiply by its cross dot product. Y to the second, comma xy, times it by the derivative. And that will give us, that's just essentially distributing the derivative functions to both of the terms. So the work total is equal to y to the second dx plus xy dy, which is the work. And then up to this point, we just need to identify that y to the second power. That's the y value of e to the t that we're going to substitute in for y. So e to the t, and this will be to the second power dx, or the fact that since we have converted from our xy's to our t's, tells us that we're just going to incorporate the dt. Identify that x is t, your y value is e to the t, and this is dt. And then, again, we're trying to find the integral from 0 to 1, because that's the domain that we're trying to look for time. It starts from 0 and it goes up to 1. From 0 up to 1. The work is from 0 to 1 of e to the 2t plus t e to the t power dt. And then just simple integrals from here. The integral of e to the 2t is 1/2 e to the 2t. And as for t et, we're going to use the tabular method in order to find the derivative, the integral. So I'm going to let t be the derivative, and we're going to integrate e to the 2t. And that becomes, the derivative of t is 1, and the derivative of 1 is 0. The integral of e to the 2t is 1 half e to the 2t. And then we have to do another row for that, so 2 times 2 at the bottom will give us 1/4 e to the 2t. And let's not forget, apply the negative and just multiply. So now we can be able to integrate this. T times 1 half e to the 2t. That spells out to be 1 half t e to the 2t. So 1 half times t, 1 half times t, and e to the 2t. Now, for the second one, this is minus 1 times 1/4 e to the 2t. So that's negative 1/4 e to the 2t. And we're integrating this from 0 to 1. We can be able to just substitute the 1 and the 0 to then find a difference from the function. 1 half e times 2 times 1, that's just 2, plus 1 half times by 1, e, 2 times 1 is just 2, and then 1/4 times e to the 2t, that becomes 2, so that's e to the second, minus, and then now we substitute the 0. 1 half e, and this is 2 times 0, which is just 0, plus 1 half. But I see that there's a t here, so that will be substituted as a 0, but 0 times anything will just be 0, so I'm just going to cross that out. Minus 1/4 e to the 2 times 0, so that's e to the 0th power. And be careful about evaluating. This is 1 half e to the second plus 1 half e to the second minus 1/4 e to the second minus, and e to the 0th power is 1, and 1 times 1 half is 1 half. E to the 0th power is 1, 1 times 1/4 is 1/4. I see that we can add like terms. 1 half plus 1 half minus 1/4. So that's 2 halves. So that's essentially 1 whole. And then 1 whole minus 1/4 is now 3/4 e to the second minus, and then 1 half, just multiply this by 2, So that's 2/4 minus 1/4 is now 1/4. And the fact that we're working with work tells us that we need to incorporate the specific units as work units. And granted that you can actually convert this into a decimal format, but in most cases in your class, you will need to just keep it in exact form, since calculators cannot be used for exams. So the total work done by the force field of y to the second xy on a moving object of y equals e to the x from 0, 1 to 1e is 3/4 e to the second minus 1/4 work units.